we are, bioremediation. It is defined as a technique in which by using living organism to reduce the pollution in the environment. So bioremediation is not just applied to soil, it could be applied to air, water, all sorts of things, as long as they use living organism. Now, the key to this bioremediation lies on one material. It's called enzyme. Now, enzyme is a living catalyst. It's not accurately called catalyst because usually catalyst is a mineral. It's a non-living thing. But for living things, it consists of primarily organic. And enzyme is organic compound. It is a protein. It comes from living organism. And this will going to accelerate a lot of reaction. So it's quite safe to say the reaction that they're accelerating is hydrolysis. Hydro requires water. Lysis means breaks things apart. Now, the item that is intended to be broken, of course, is the pollutant in this case. Which is why, when you look at bioremediation, most of them they are used to address the organic contamination, such as chlorinated hydrocarbon. Now, chlorinated hydrocarbon, as we learned before, is a persistent organic pollutant because they are non-biodegradable. Well, there is a reason for that. They are non-biodegradable because they kill the organism first before they even can get a chance to degrade them. But in nature, bacteria, or more accurately, microorganisms, they mutate very fast. So, like for example, if today we use antibiotics excessively, these antibiotics will be overcome soon because due to the fast mutation of this microorganism, their genes can actually adapt. So let's say before this, they were killed by a certain antibiotics, but today they don't because when they were killed, at the same time, the surviving bacteria or the surviving microorganism may change their DNA in a way that they can adapt. So this is how a good bacteria for bioremediation is developed. They keep killing the same bacteria, and then they try to find, is there any survivor? Is there any surviving bacteria? The bacteria that survives most likely has the gene to overcome the toxicity of PCB, which is in here chlorinated hydrocarbon. So those bacteria, they'll isolate and will be used further for bioremediation. Now, in this case, it's not just PCB microbes can be used. They can also be used for other types of pollutants. Most likely, it's organic pollutants. So these organic pollutants covers, it could be PAH, poly aromatic hydrocarbon, it could be PCB, the man-made hydrocarbons that is very toxic. It also can be used to reduce the nutrient level. Now, in this case, the nutrient, what we say is nitrate and phosphate, not just sulfate. It's more of phosphate because phosphate and nitrate together, they cause eutrophication. And I think this is exactly what sewage treatment plant are using. Sewage treatment plant, they don't use chemical. They just collect all those sewage. That means the pool that you, after you go to the toilet, all those waste, the human feces, the urine, they all channel to one container. So this tank is managed by IWK, Indoor Water Consortium. So this tank contains only bacteria. So they just let the bacteria do its business. They will consume all this excessive nutrient, and by consuming this nutrient, they will reduce the so-called pollutant before they can release to the environment. So there are a lot of bioremediation happening right now in any sewage treatment plant. Exactly. However, the examples that we're going to talk about, this one is, we're going to refer to the pollutant of interest, like persistent organic pollutant is what? Okay, not just nutrient. So it has been a long history when you talk about the progress of bioremediation. It first discovered by someone, so you can read it yourself if you wanted. But our point right here is we're trying to recognize the characteristic. Okay, so for the purpose of this course, we were going to identify what is required, what is the characteristic of bioremediation, and how bioremediation is being conducted. So the first point is not important. The second point is the important one. So I'm going to elaborate. Yeah, second point, bioremediation technologies can be generally classified as in situ or ex situ. You should remember these two words. think I told you before, right? In situ and ex situ, last two chapters, sorry. In situ means you do bioremediation on site. If the place is contaminated, you do it right there. That's called in situ. If you bring the soil into other place and you do the remediation, it's called ex situ. Okay? So usually, in situ is much more preferred, because if you do it on the spot, you will cut down the transportation costs. So very economical. And why not? Then you can do it right there. Just do it right there. No need to transport anywhere lah. So which is why bioremediation is preferred, because it can do it. Bioremediation can be executed on the site without having to move anywhere. And it's actually quite good reason as well, because if you use ex situ, not only it involves cost, you're also going to like interrupt the soil structure. In some way, the soil structure will going to suffer. So not really a good idea lah. Okay, so I'm going to continue with the example of bioremediation. So in this slide, we're going to concentrate on just three techniques: bioventing, biosparging, and bioaugmentation. The other few techniques, such as phytoremediation, bioreactor, composting, rhizofiltration, biostimulation, I think you can find your own further information if you want to know. I think phytoremediation, we already talked about it like last time, so we already covered that. So today we're only going to cover those three that is bolded right here. Yeah. Anyway, the others, they are quite similar. It's just the way they were conducted, and also the pollutants they are addressing slightly different, but most of it they are like quite similar. Okay, so I'm going to start with bioventing. Now the name itself tells you that air is involved, because venting means you're releasing some air from high pressure. um yeah, you can find yourself now. Venting is actually a name. Bioventing means it's a technique that uses microorganisms, and they use primarily air. Okay, so in this case, this technique is definitely in situ. It can be used ex situ, but like I said earlier, why? Then if you can reduce the cost, then might as well do it in situ. So a lot of this bioventing actually is done in situ, because out of the three techniques that we have talked about just now, bioventing is the cheapest. Why it is the cheapest? Because like I said, you only use air. Air is like free. You just use a pump, you pump air into the soil, and that's it. Nothing else is used. That is why bioventing usually is the first the first preferred technique lah, if the contamination is not very severe and it doesn't brings too much of impact to human health. So if it's like a minimal impact, and it doesn't require fast recovery, so bioventing is actually a good idea. Very cheap. Use a pump air. Now there is another requirement. Bioventing also needs to be done on a soil column. The area must be airable. Airable means when you pump air inside, the air actually can move around in the soil. Sounded quite important, quite impossible, isn't it? Because we know that in the soil we have moisture, and because of the existence of this moisture, it creates some resistance in terms of permeability, which is true. So there is a big requirement. Before bioventing can be successful, one have to ascertain that the soil is unsaturated. So in this term, unsaturated means not saturated with water. This is what they mean. So like I said, it's quite easy to use the activity. You pump air inside. And why just use air? Because we know the soil already have organism, indigenous microorganism we call it. So indigenous means the microorganisms that's already in the soil that possibly can do the remediation job. Because if they exist there, certainly they have tolerance. They can endure of the pollutants. They were not killed by the pollutants, maybe. But you know, when they are deep inside the soil, it's actually hard to make them propagate. When they're deep inside the soil, they need a good condition to survive. Now, in this case, by pumping air inside, you will give them extra oxygen. Now, these bacteria, when they have extra oxygen, works more efficiently. At least they can respirate more efficiently, and by respirating more efficiently, they have more energy to propagate. So that is the entire concept is being given here. You don't give nutrient, you just allow them to do their own job, but in bioventing, you just give them extra oxygen. Sometimes it may work, sometimes it may not. So that's why, if necessary, nutrient is added, because if you just give them oxygen, okay, they can breathe, but they're still hungry. So in order to make them work much more better, certain times nutrient may be needed, especially to soils that are not too fertile. Some soils are not fertile, let's face it. Yeah, fertile soils, they may be existing, but not too many. Yeah. If they're not fertile, you give them more nutrients, and some of the soil also may be quite dry. If they are dry, once again, you also need to give them enough water. So the keyword is enough water, not too much water, because if it's too much, it becomes saturated, and there you go. You cannot use bioventing. Okay, so I'm going to the slide. So this is what it means by saturated and unsaturated zone. I believe we have seen this diagram before in the environmental sampling subject. And so you can see by yourself, yeah. I won't going to explain too much of these things, so I'm going to carry on. And bioventing remediate soil contaminated with fuel. So in this case, they were so many things that you can address by using bioventing. Now, not just it will use the bacteria to degrade it, but sometimes bioventing, it's more of a physical process in which when you pump enough air inside the soil, the subsurface soil, they will have a build-up of air pressure. So you pump more air, they will have pressure. So there must be some way that this pressure can be relieved. If you pump air into it, somewhere the air will be coming out from the soil, isn't it? Now in this case, by saying it's physical, meaning that if you pump air inside, the air will help flush these contaminants out. So the volatile contaminants such as solvent, majority of solvent, they are volatile. And if they can be volatilized, then the high pressure will just simply flush it out without having to need bacteria to degrade them. Similar with pesticide as well. If they can be flushed out, yes, this is how they can be flushed out. And also some of the major contaminants. So bioventing have two functions, two ways they can remove the contaminants. Number one, they give oxygen so that bacteria is better in doing their bioremediation. And number two, just flush out the contaminants. So in terms of bioventing, I'm not sure next slide they have anything or not. Okay. So I think these few points we're going to explain further on that one, on how bioventing can be used to flush things. So how it's done, number one, you inject the air, compressed air into the contaminated soil, and then, as I said to you just now, degradation by the bacteria because they have extra oxygen. The bacteria can do the bioremediation much more better, and then the rate of natural degradation is generally limited by the lack of oxygen. So yeah, like I said, they will need more oxygen so that they can do this biodegradation. And then I will move on to the last point. The fourth point is a repeat of what I said. So the last point, in contrast to soil vapor vacuum extraction, bioventing uses low airflow rates to provide only enough oxygen to sustain microbial activity. So coming back to what I said to you just now, the one that will flush out the contaminants, they actually have another name. They call it soil vapor vacuum extraction. Well, although the name says vacuum, but essentially is due to pressure. Like you pump pressure inside, it's easier to extract. So If it does not involve bioremediation, if bacteria is not really a concern, if you just want to flush out the contaminants, the technique is called this one, soil vapor vacuum extraction. However, if you're going to involve bacteria in part of this remediation technique, it's called bioventing lah. And there is a difference between these two techniques. If flushing is your main, if flushing out the contaminants is your main mechanism, it's called extraction. So you use high pressure to do it. Now, if the pressure is not very high, then it is more akin of bioventing. So bioventing is cheaper because it does not involve too much of energy use, yeah? Just enough oxygen into the soil. But even if I say low energy use is still quite high, because you can imagine the soil, and then if you know physics, this is not really an easy task to complete actually, because if you're talking about big soil area and want to inject enough air, quite a lot of energy would be subjected. Okay, so continuation with the bioventing, there are 3 steps to do it. Passive bioventing system use natural air. So this one involves the use of a pump to inject whatever the air is available in the atmosphere. And then there's another thing. A one-way valve installed on the vent well allows air to enter the well when the pressure inside the well is lower than the atmospheric pressure. Now, when this bioventing is conducted, there will be 2 wells. One that you pump inside, the other one that probably going to release the pressure if there is. So number 1 is the first well, number 2 is the second well. Number 1, of course, you have pump that pumps air inside. Number 2, nothing. You just leave it as it is and the air will come out. But frankly speaking, number 2, usually we're going to have like a safety device, so-called, in which usually a sensor will be placed there just in case if the outlet, if the air coming out of the soil is toxic, it will be picked up by the sensor. So this usually is installed. Yeah. Apart from that, probably some of the side of the of this well, they will go to, once they picked up the signals of the contaminated air, well, probably it might have a fail-safe mechanism to stop the entire process, or maybe they will have a mechanism to trap those contaminated air. But in essence, if you're talking about bioventing, we don't expect, um, high concentration of contaminants coming from the second well. Because why? You pump air inside, the bacteria should do its job. So if the bioventing is successful, by the second well, whatever the air released from the second well should not be too dangerous if bioventing works. If it doesn't work, then something must be done. Either you put more nutrient or you put a better bacteria inside. So number 3, when atmospheric pressure drops below the subsurface pressure, the valve closes, trapping the air inside the well. So like I said, number 3, it's a fail-safe. If the pressure is not too high, then it will close by itself, and then preventing outside air from coming in and further complicate the entire bioremediation process. So this is example, like I said, air injection, and then it will going to give more air so that the bacteria already contained inside this contaminated zone will further do its job. Okay, so the advantage, obviously, the cheapest, because only use air. The rest of it, I won't going to say too much. One of the ways is the cheapest because it use only air and it doesn't require any external transportation of the soil. Of course, it does have limitation, the problem. Now, if you're going to use just the bacteria and air, of course, you get what you pay. You pay cheap, you also get cheap quality. Now, not to say cheap quality, I mean, it depends, like I said. You can use this technique if it allows you, because if the contamination is very low, bioventing could be used because you are dealing with low level contamination. However, If the contamination is very high, then maybe you have to switch on a better technique, use better bacteria, put more nutrient, or maybe you have something else. But here, the major problem is that we all know soil is not very permeable, because especially in Malaysia, when we have high rainfall, most of the soil in Malaysia were used to be quite wet, and because of that, the permeability, the air permeability is usually a problem lah. You pump air also, it will not go through because they already have moisture. So if you pump air inside, maybe not the air that comes out, maybe the moisture is the one that comes out. So okay, it only works in unsaturated soil lah. And then water tables also fluctuate, so that gives us uncertainty from day one. If it's like dry season, yeah, you can use it on day one. Day two, raining. Then what? It's already soaked up with water. Can you use it? Of course, you cannot. You have to wait until the water table comes down so that there's enough permeability where you can pump air. So that is another thing that is also a factor. It's not really that efficient because you need to deal with a lot of uncertainty. Most of the time, weather lah, yeah. Then aerobic biodegradation of many chlorinical may not be effective. Yeah, um, because we are using indigenous bacteria. Like I told you, mutation bacteria can do it. But when I say mutation, kan, it's not like it happens like in 1 day or two. Usually mutation takes a long time. I mean, take example lah. Evolution of life. How many years? Millions and millions of years, you know. But bacteria can cut down. Bacteria mutation do not need millions of years, but it's still going to take a few years to do its job. So because of the fact that bioventing uses indigenous bacteria, the effectiveness is not that high, not very high. And plus, bioremediation also itself is already very slow. So if you're person which who is in a hurry to see results, bioventing may be a bit downside on that one. It needs time, yeah. Okay, so monitoring vapor at the soil surface may be required. Like I said to you, the monitoring device just as like a fail safe lah to discover if there's any uh, toxic air release from bioventing. That is a requirement.